All right, I'd like to switch gears a bit now and talk to you about the anatomy of the output of the cerebellum. And we'll consider this anatomy really in two steps. First, I'd like to talk to you about the ascending outputs from the cerebellum. They're ascending anatomically in that they leave the cerebellum and they enter the brainstem via the superior cerebellar peduncle, and then they ascend in the superior direction to encounter targets in the brainstem and in the motor thalamus. So the source of these outputs are the deep cerebellar nuclei, specifically the dentate nucleus, and perhaps the interposed nuclei as well. But the dentate nucleus quantitatively is the largest and most significant of the sources of these ascending cerebellar outputs. So recall again that we've got a bit of a challenge, that we've got one side of the cerebrum is related to the opposite cerebellum. So for the outputs of the cerebellum to impact these upper motor circuits, there needs to be a crossing of the midline, a decussation. And here's how it happens. The deep cerebellar nuclei in question, namely the dentate nucleus, grows an axon that exits the cerebellum through the superior cerebellar peduncle. And some of these axons will ascend and terminate in the ventrolateral complex of the thalamus, the ventrolateral ventrally anterior nuclear group. There are other axons that will terminate among upper motor neurons in the superior colliculus. Probably not the same axons, but nearby axons. So these ascending inputs target the motor thalamus and the superior colliculus. There are also collaterals that will reach yet a different target, the red nucleus. Pardon me for writing the word red in blue, but the red nucleus also receives collaterals from these axons as they make their way through the midbrain on their way to the thalamus. Well, the motor thalamus then, as you know, will send its inputs to the primary and the premotor cortex. And at this level, we believe that the error correction signals can modulate the output of the motor cortex. Here's an anatomical view of these outputs, and draw your attention again to our beautiful dentate nucleus here. So there are cells that sit in this dentate nucleus that grow axons that stream out across this beautiful superior cerebellar peduncle, which is this big bundle of white matter that we see here and there. So we'll call that superior cerebellar peduncle. And notice that the decussation is actually outside of the cerebellum in the upper part of the pons, near the junction of the pons in the midbrain. And the axons branch and terminate. Some of them will in this red nucleus, which we find here in the midbrain, and then others will terminate up around in this region, the area of the ventral anterior ventrolateral complex of the thalamus. So this decussation then allows the appropriate hemisphere of the cerebellum to relate back to the upper motor circuits that govern the same part of the body. Now let's talk about what we might call the descending outputs of the cerebellum. Anatomically descending, not up to the motor thalamus, but directed towards brainstem targets. So recall again that we have our deep cerebellar nuclei. Near the midline, we've got the fastigial nucleus, and a bit more laterally, we have the dentate and the interposed nucleus. And for the descending inputs now, we focus mainly on the connections to the reticular formation of the brainstem. Now, the fastigial nucleus also has some connection to the superior colliculus, but it's probably not as functionally significant in our brains as is the larger output that's coming from the dentate nucleus. So we'll focus mainly on the right side of this figure to consider these descending outputs. So again, the major output of concern here is connections from the medial part of the deep nuclei of the cerebellum to the reticular formation of the brainstem. And the reticular formation, as you know, give rise to projections down to lower motor neurons and the medial part of the ventral horn of the spinal cord. So these are motor neurons that are going to be mainly concerned with posture and the movements of the proximal muscles of the limbs. Now, I mentioned in our introduction that the vestibular nuclei are sometimes considered deep cerebellar nuclei that are displaced out of the cerebellum and into the brainstem, and here's why. The vestibular nuclei receive input directly from Purkinje cells of the vestibulocerebellum. And these nuclei then are in a position that's somewhat similar to these deep nuclei. Although in this figure we chose to put them outside of the cerebellum as they actually fall anatomically, right alongside the reticular formation neurons. So these vestibular nuclei then give rise to their own spinal projections, where they helped to maintain balance under conditions in which there's been some kind of acceleration of the head, often associated with a disturbance of postural control. Well, when you come back for part 3, we'll talk about functions and dysfunctions of the cerebellum.